In the last session, we have discussed about chemical classification of matter. Now let's discuss about element compound mixture and their classification. Element. An element is defined as a basic form of matter that cannot be broken down in simpler substances by any chemical reactions. An element is a pure substance made up of only one type of particles called atoms. An element cannot be broken down or converted into anything simpler than itself by a physical or chemical change. Likewise, it cannot be formed from simpler substances. So, elements are the basic substances from which other substances can be made. Examples of elements are hydrogen, oxygen, nitrogen, copper, silver, etc. Atom. An atom is defined as the smallest particle of an element which takes part in the chemical reaction. An element is made up of same kind of atoms. Elements are monoatomic, diatomic, triatomic, polyatomic, etc. Example: monoatomic elements are helium, neon, argon, krypton, xenon, radon, and metals. Diatomic elements are H2, O2, N2, F2, Cl2, Br2, I2, etc. Tetraatomic elements are P4, As4, Sb4. Octatomic element is S8. Molecule. The smallest particle of an element or compound which has independent existence and can retain all the properties is called a molecule. Examples are H2, O2, N2, H2O, CO2, etc. Molecules of elements. As they are made up of only one kind of atoms, they are called homoatomic or homonuclear molecules. Further, depending upon whether the molecule contains only 1, 2, 3, etc. atoms, they are monoatomic, diatomic, triatomic, etc. Respectively, for example, helium, neon, argon, etc. are monoatomic, H2, O2, N2 are diatomic, ozone, O3 is triatomic, P4 is tetraatomic, and S8 is octatomic molecules. Characteristics of an element. Each element consists of only a single type of atoms. No two elements contain the same type of atoms. An element is a pure or homogeneous substance. It has its own fixed boiling and melting points. An element cannot be broken down into simpler substances by any chemical or physical reactions. An element may chemically react with another element or compound. An element may occur in solid, liquid, or in gaseous state. An element may be metal, non-metal, metalloid, or noble gas. Number of elements. The elements may be regarded as the building units of the universe. Scientists believe that 92 different kinds of elements exist in nature. Others have been prepared in the laboratory by artificial means during the course of nuclear research, and the total number of elements known to the man so far is 118. Elements found in nature. While a majority of elements occur in nature in combination with each other, some of them like oxygen, nitrogen, copper, gold, and so on also occur in a free state, that is, in an uncombined state. In the Earth's crust, comprising the outer portion of the Earth, oceans, and air, we find that oxygen is present to the maximum extent. Next comes silicon, which is an essential constituent of the rocks. The approximate average percent by weight of the various elements of the Earth's crust is given below. Check the table. Oxygen 48.85% by weight. Silicon 26.03% by weight. Aluminium 7.28% by weight. Iron 4.12% by weight. Calcium 2.18% by weight. Sodium 2.33% by weight. Potassium 2.33% by weight. Magnesium 2.11% by weight. Hydrogen 0.97% by weight. Titanium 0.41% by weight. chlorine 0.20% by weight, carbon 0.09% by weight, and other elements 1% by weight. Elements found in the human body. The elements that biochemists have found to be most important in the human body are oxygen 65%, carbon 18%, nitrogen 24%, calcium 1.6%, phosphorus 0.9%, and few others. Classification of elements. Elements are classified on the basis of their properties and also basis on their subdivisions. On the basis of their subdivisions, elements may be solids, liquids or gases. Mercury, bromine, cesium and gallium can exist as liquids at 30 degrees centigrade. Hydrogen, nitrogen, oxygen, chlorine, fluorine, helium, neon, argon, krypton, xenon and radon exist as gases at room temperature. Remaining elements are solids. Classification of elements on the basis of their properties. Check the given table. Metals. Metals have metallic luster. Metallic luster means it have shining nature. Non-metals do not have luster. Metalloids have properties midway between metals and non-metals. And noble gases have properties that are gaseous in nature. Metals are good conductors of heat and electricity. Non-metals are bad conductors of heat and electricity. Metalloids contain one kind of atoms and are monoatomic. Noble gases are chemically inert. Metals are malleable, means beaten into sheets, and ductile, drawn into wires. Non-metals are non-malleable or non-ductile. Noble gases occur in a free state in traces in the atmosphere. Metals contain one kind of atoms and are monoatomic. Non-metals contain one kind of atoms and are monoatomic or diatomic or polyatomic. Noble gases contain one type of atoms and are monoatomic. Examples of metals are sodium, potassium, iron, lead, etc. Examples of non-metals are gaseous, hydrogen, chlorine, oxygen, etc. Examples of metalloids are germanium, arsenic, antimony, bismuth. Examples of noble gases are helium, neon, argon, krypton, xenon and radon. However, there are some exceptions in metals and non-metals. Exceptions in metals. We have discussed that metals are solids. Mercury is a liquid metal at room temperature. The second exception is zinc is non-malleable and non-ductile in nature. The third exception is tungsten is a pure conductor of electricity. Exceptions in non-metals. The first one is iodine and graphite are lustrous. The second exception is carbon fiber is ductile but not malleable. The third exception is graphite is a good conductor of electricity.